you just, can you see? Just go to that link. Oh wait, let them, yeah. And no, no, oh no, not yet. So once you go inside, there's the stuff for week 3. So you can see BI bot, the helper libraries which we'll be using today. Alright, let me increase that. The stock prediction bot things, the PowerPoint, and the helper libraries for this extra stuff, and the training data. The prediction bots and the BI bot, they're not the entire code. They're mostly a visualization of what you're going to make. So by the end of this semester, you'll be able to make those two. So if you download this, like if you go to the BI bot thing, it's in HTML format. So if you click on it, you have to press the raw button, right? You have to press that, and then you have to right click on the raw button, save link as, right? And then just save it to like my documents or somewhere. And then now you can open it. So you just open. Okay, so this is what you will be able to do. So for example, this is the BI bot. So if you give it some data, instead of writing code and stuff, after you wrote everything, you can just like invoke the analyze command, and if you give it a target, it will show you this is the top 3 most important features, and it will highlight the comparisons between the data. And so this is the BI bot which you will make. This will be extremely useful if you just want to just get it some data, whatever data you like, just plug it in, and then you don't need to do anything. So that's a business intelligence bot thing.
This is based on Titanic data. So it's basically a data set of all the people who survived and died on the Titanic based on various factors. So here you can see the 3 most important factors were the age, the fare, and the class. So first, second, or third class. And as you can see, 1 is survived, and 0 is dead. So all the black dots are people who were killed on the Titanic, and all the white dots are those who survived, and you can see the correlation here clearly.
Yep. And so why do we need to do this? Like, how is this different from other methods? Well, if you have a data set which has like 10,000 columns, which one are you going to graph? Are you going to graph all 10,000 columns? So using the business bot, it will select the 3 highest, most important variables, and it will just graph those 3. And from here you can see that the black dots, the dead people, and the white dots, the survived. You can see how it's kind of, if the P class or the passenger class is 3, right, and the fare is low, you can see how they're mostly going to die. However, on the other hand, if the P class is 1, which is the best, and the fare is higher, you can see on the bottom layer how majority of them survive. And so you can use this to draw insights.
Yes, so as Daniel was saying, you can basically relate this to real life. Obviously, you can see why this might be the case, because first class passengers were prioritized on the limited number of lifeboats they had, and the rest followed. So that's why most of them survived here, and most of the casualties were in third class.
Yep. Okay, so that's the BI bot. The next one we have, the stock prediction. Okay, so this is CBA share prices from 2000 to 2017. So if you go down, so this is the training, and so that is I think this is 2016. No, yeah, approximately. Wait, can you go down a bit? It's from. Yeah, I think it's okay. So the testing. So the one which you show go off a bit. Yeah, this one, the one you see now. That is that's testing data. So it trained from 2000 to 2016-ish, and then it tries to predict what's going to be the trends from 2016 to now. And you can see, obviously it's not extremely accurate, but at least you can draw the big trends. So if you're like a stock trader who is mainly focused on long-term return, then this will be extremely good for you, because you can see how it kind of predicts the downward trend. So at the beginning of the month, it will predict that it will go down. And most likely, it's not 100% accurate, but it's good enough. that it will show you a trend. So for example, if you see the highest trend, I think that's, I don't know, three-ish months, I don't know, a few months ago, you can see how at the peak it will predict it will go down, and in fact it did go down. And so most of the predictions are okay. Some of them are obviously not good, but
Yeah, like this one here, well, you can see that it is correct in the short term because it did go down, but it didn't do that good a job in predicting this huge surge.
yeah,
So this one is still correct though. Like if you see some of these, they're much better in terms of the accuracy, of course. Here it predicted a long-term decline, and then here it's predicted that it would stabilize, which clearly it did.
yeah, they kind of just, yeah. So just remember the lines, they don't indicate the share price, they just indicate the trends. So that's why you can see how the lines don't match the areas of the real trend. So the real trend is in blue. The lines just indicate the change. And so, yeah, if you keep going,
So,
yeah, that's just,
how many
yeah.
factors did you put in to do this data analysis?
This is just, oh yeah.
How many factors did you enter? How many factors, variables did you
Oh,
enter?
this is just one. This is just predicting through shares.
It's just
That's
one.
why it's not that accurate.
Okay.
If you did multiple variables, it would be
Yeah,
a bit.
a little bit more.
It's based on a
Okay.
long short-term neural network, so it just uses this one feature and predicts the trend based on that.
Yeah. So it just uses old share prices to predict new share prices.
Okay.
But if you do, if you want to put like Twitter, Twitter sentiment or something like that, then you'll have to do more modeling. So yeah, it will most likely become more accurate, but we're not sure. Yeah. Where is the? Wait, what's next? Let's stop. Okay, so these are the helpful libraries we'll be using. Okay, so these are the libraries you'll be using. Don't worry, you don't need to code any of this, you just copy paste. But we'll be teaching you every single step and stuff, so you'll be most likely the stuff you'll be learning will be different, but at least so you can kind of execute code yourself without actually coding. So you can kind of feel that you have the power in your hands to do artificial intelligence and data science.
So yeah, we basically use various models and show you the algorithms, how they work.
Yeah.
So random forest decision trees, regressions, and SVMs. So we'll get into
So to call the model, all you need to do is 3 lines, right? So you get your data, right? Your training data or whatever, your target which is survived. You choose your model, whatever model you like, and it just predicts the training data. And you can, we haven't done testing data, but currently it's just training data. So with 3 lines, you have artificial intelligence in your hands. Yeah. So should we do the other example?
So you actually wrote this program in the background already.
Yeah.
So this is just for us to the users just enter the data within.
Yeah.
it's a
So
helpful
have you,
line.
what's your program like? Is it like 10 pages of that?
It's 100. It's 100 lines. It's not that. This for the real bot, it will take quite a long. But this is just basic and all the mean imputation and stuff like that. So it's basic, but it mostly work. Yeah, it will work. Should we? Wait, do you have the?
Yeah, I was going to show you guys a simulation of a self-driving
Okay, which
car.
one? No, not this. Where is it? Let's find it.
It's still training, unfortunately. Like it'll take around 16 hours, so maybe next week I can bring that in.
So this is another these are other algorithms called reinforcement learning, and they also use evolutionary algorithms and neural networks and stuff. So what it does is, have anyone heard of Google's AlphaGo, the one that beat the world's best Go players and stuff like that? Maybe people don't really find that important and stuff, but but in Go, the number of possibilities is, they said it's more than the number of atoms in the whole universe. So how can a computer win if it has to go through every single one? Like it can't check every single possibility. But in fact, they did it, right? And they won. This is not Google, but this is another one. So this is you can plug in your own models like games and stuff, and it will train the game to pass the game, right? And so this is So you can, this is if you want to check this out, you can go and open AI Gym and stuff. Other cool stuff, which is also AI. Oh, this is more data sciencey. Where is? Has anyone heard of this? This is the whole world for temperature, current, wind, everything. Okay, and this is visualized in a way. So if you go to like ocean, you can go to ocean mode and all the currents, and this is in fact data science as well. So this is what you can do if you get into data science. And chemicals, particulate, let's just go particulates. So if you go to, let's do PM 2.5. Yeah, so this is PM 2.5. You can see how the, you can just go around, right? This is real time and backward. You can go backwards, forwards, and it can predict forward as well. So these are the other stuff of artificial intelligence data science. You probably never heard of this before, but now you know. Let's do one. This is another one. Oh, you can also change the projection and stuff like that. Yeah.
So yeah, just for a more like different layout.
Let's go to one more. Let's do one more. There's another one. This. No, this. Okay. I think it's this. I think it's this. Oh yeah, this is. So they use, this is a food prediction algorithm for USA. So you can use Twitter data and stuff like that, and it can predict. So if you use Twitter data, it can predict when an outbreak. Right, if you select a state, it will tell you the influence on other states and stuff like that, and it will tell you like a prediction of a possibility of flu that will occur during the time. So this is what you can do with artificial intelligence and data science. Yeah, this is based on sentiment analysis and other past trends and stuff.
So what it does is it looks at Twitter feeds and basically tokenizes each word for a particular feed, and then it analyzes whether that's positive or negative. We can show an example of that using TextFlow.
Oh yeah. Later. No, I don't have it. But yeah, we will show you an example later. Okay, so let's get into the more fun stuff. Okay, so I would say there are three. Wait, is that over?
It was currently focusing on that.
Okay, so there are in machine learning and artificial intelligence and data science, there are three main sections, right? And the three main sections include supervised, unsupervised, and I would say reinforcement is another one. Right, and those three sections, supervised learning means that I have a target, right? So remember the Titanic one? I give you a target. So you give it a target, Y, right? And it tries to get the X or the data, and it tries to fit a model to make it to Y. So that's supervised. Unsupervised is you don't give it any target, and you just get some data, right? And it tries to draw some trends. So that's unsupervised learning. And reinforcement learning is the thing you saw, the OpenAI, the game bot thing. You just give it some input. You give it like a target, not really a target, but it's more like a utility function. So what you wanted to get, more money, more stocks and stuff. So you can also make this on stock trading as well. So if you make a bot, you can use reinforcement learning, and it tries to get the X, so the object, to do something to get more profit or more happiness, something like that. So these are the three main sections of machine learning and artificial intelligence.
Yeah, so with supervised learning, basically the main difference between these two is with supervised, your output is categorical data. So it basically gets an input, uses a function to map it to a particular class. For example, with the Titanic data set, we're predicting whether someone survived or not. Those are two different classes, survived and didn't survive. And with unsupervised, we're basically just predicting the trend, as Daniel said. So, for example, house prices. So if you have various factors affecting house price, and then you do perform a linear regression, then you can using certain factors as inputs, you can predict the price that it may be. So it's not necessarily into a particular class. And with reinforcement, basically, it's used for games, especially chess. This is how chess AI bots are programmed. So basically, when there are many ways of doing this, but a particular one is where you let the algorithm randomly do some task, and when it gets it correct, then you provide feedback, and that basically alters its state, and that will then perform better than it did previously.
Yeah. Also, yeah. There are other algorithms which kind of don't really fit in these categories. For example, evolutionary algorithms. I would consider them as reinforcement, but not really. Evolutionary algorithms try to get something, like some action, and it tries to mutate the action in different methods. And these mutations of actions, it will keep doing it. And so on. And it tries to get the best one. So it's kind of like evolution, right? That's why it's called evolutionary algorithms. And this kind of fits in reinforcement, but technically not, but yeah. Those are the other different types of algorithms. For unsupervised, okay, so what you can do. So supervised, like we can say, you can predict a target, right? You can also predict, so this is mainly for targets. So if you want to increase profit, if you want to predict survive for insurance and stuff like that, then supervised is good for you. Unsupervised, for example, anomaly detection. Pretend if you want to know a burglar came into your house. How are you going to do that? You probably have to use unsupervised learning. So unsupervised means you just have data, but you don't have a target. But you kind of know that something's out of place, and that's unsupervised.
That's the stock predictor which we showed.
Yeah, kind of, yeah. And evolutionary will be used in chemistry. So you can make new medicine or something, or elements and stuff like that with evolutionary algorithms. Okay, so we'll be going on our first model. So now we'll be talking. Okay, so within these three main big sections, there are also two different methods. The two different methods include classification and regression. So classification is pretend you want to predict survived or not, so it's 0 and 1. See, this is discrete variables, there's only 0 and 1. But regression is when there are multiple the regression is when the variable is continuous. So if you want to predict house prices, it's like $1,000, 1,001 cents, and stuff like that. So those are the two different sections. Now we'll be looking into classification models. So the first model, the first most main model, which you will have to do, you will have to most likely understand this, is logistic regression. This is for classification. What is logistic regression? Logistic regression is the same has anyone did linear regression before? So it's just fitting a line to a data set, right? Logistic regression is the same thing, kind of. It's the same family of linear regression. The only difference is you're trying to okay. Right, linear regression, if you have some data, you want to fit a straight line, kind of. But obviously, don't get confused. Linear regression does not have to mean it's a straight line. If you have a parabola, you can also fit a parabola with linear regression. So don't get confused by the name. Logistic regression tries to separate your data. So if you have two different classes, right, 0 and 1, it tries to get some line that kind of separates these two boundaries. And this is logistic regression, kind of. Not really, but this is kind of what happens. And so you can see how it tries to fit the best line, which kind of separates the data. So this is like underfitting the data. This is kind of the best. And this is just overfitting. So if you put too many variables, if you try to if you remember the parabola example thing, pretend if you want to, if you fit a parabola, it's good, but it's kind of overfitting. So if you do this, if you draw a parabola, it doesn't really make sense anymore. But that's overfitting, so you want to find the best decision boundary to cut it off. Yeah. Oh, do you want to? Yeah.
Okay, so this is another method of machine learning called decision trees. So it's basically a hierarchy of decisions which lead to a final output. For example,
Do you want to? Oh, I do you want to do decision?
Okay, so yeah, we're going to discuss random forest, which is basically several trees combined. So this method basically is another method of prediction, just like linear and logistic regression, but I'll just make up some test data. Thank you. So let's say you want to predict something like whether we're going to play tennis or not today, and it's based on some factors. So let's say rain. So let's say rain. What other factors?
Wait, what is this?
Predicting whether we play tennis.
Oh.
So let's say tired.
Yeah.
Tiredness.
Just do two.
Okay. And these two factors will determine whether we play or not. So play. So let's say if it's actually we'll make it, these are pretty discrete. So we'll just change that to temperature. So temperature, tiredness, and whether we play, that will determine whether we play or not. So 1 we do play and 0 we don't. So let's say if the temperature is 20 degrees Celsius and tiredness, let's mark this on a scale of 1 to 10. So let's say temperature is 20 degrees and we're tired 5, so like half. And if that's the case, we play. If tiredness is 9 and if it's too hot, then we don't play. And we continue doing that. So say 15 degrees Celsius, 8, then we don't. And we keep adding those data points. So now you can use regression on this to, okay. So let's say we want to know temperature is 25 degrees Celsius and tiredness 4. So let's say based on that we want to predict, do we play or not? So you can use regression to accomplish this, but there's another method which can be more effective, and it's called a random forest. So how it works is basically we'll end up with a decision tree. So we have a node at each. We start with one node, and it's a hierarchy system. And then based on some decisions, it goes either here or here. And it can keep continuing as many branches as necessary. So how it works is we have the topmost condition, which will be analyzed first, and that will be depending on all of this training data. So what we do is we select a subsample n, which is generally around 66% of the total data used. So let's say this is 66% of all data, and this set is n. So n is basically a subset of the total data, 66%, and it's selected at random. And then we choose some variables n randomly, and these are randomly selected. Here we've only got 2, but there are cases where you can have like a couple of hundred variables, and so we select a random subset of the total, and we call that m. And then based on an objective function, it looks at the topmost node and determines what the best split is. Based on all of these variables we have, it determines the best split using the objective function. So let's say it determines that to be temperature must be greater than 20. So temp greater than 20. So what that basically means is that it determined that is the most useful factor to put at the top, and that will be our main condition. So if temperature is greater than 20, then we look at some other decision. I'll put that outside actually. So let's say temperature greater than 20. So we have initial weights, play, not weights. we have an initial condition, so play, don't play. Give these each, I guess you can call it a weight. Give these each a weight. So let's say if the temperature is greater than 20, then we play in 20 cases and don't play in 30 cases. So these are our current values. So based on this, currently we won't play because it's got the greatest number. And then it repeats the process of splitting at each node. So then we can say bring in tiredness, another factor. So tiredness, tiredness greater than 5. So if let's make it higher, more realistic. So let's say if tiredness is greater than 8, then it's looking more likely that we won't play. So play will become, say, 21, and don't play will become, so let's say play 8, don't play 20. So now it's looking more likely that we won't play. Again, it's not very effective, as you can see, since it's only 2 variables. It works much better when we have so a lot of variables. And so it basically keeps going, keeps splitting, until at the end you have a final decision. So play, don't play, 15, 25. So based on this decision, if we keep following it, then this will be our output. So we input these, 25 degrees fall, work our way down through the tree until we end up with some decision. This is just an example, it's not, I can't compute this in my head. So, and then we'll have some outcome, either 1 or 0. We end up playing or we don't play.
Okay, so we'll be doing some practical now, and then we will go on algorithms later. But so does everyone have? Did you download the stuff? So if you didn't, remember it's this. If you go to that website or GitHub thing, just download the stuff from there. Should make it bigger. Is it big enough?
Yes, yes.
Okay, yeah. So just go to that. Yeah, just go to that, and then once you go there, just download all the stuff in here. Okay? So not the HTML files, just the .py. So the Datasoc helper libraries. So if you go there, if you open in a new tab, right, you have all of this. Just copy paste all of this. So just copy.
Well, it would probably be easier to just
Oh no, they want
just
to
download the whole thing.
No. Oh yeah, true. Oh no, you need to. Just control that. Anyways, you just download the stuff. Put it. So if you're using Kaggle, so can you put your hand up if you're using Kaggle? Or okay. Everyone else has Jupyter notebooks, right? Do you know how to open it? Did you watch the video? Okay.
Just if you're on Mac, I think it's disabled. Yeah, it's disabled here, but
If you're on Ubuntu or Mac, just go to terminal. So just type in terminal Jupyter.
just type in Jupyter notebook.
Yeah, just type in that. If you have Mac or Ubuntu or whatever.
And make sure you're in the right directory as well, because
Oh wait, I spelled it wrong.
yeah.
Right, this is for Mac and Ubuntu and Linux and stuff. If you have Windows, you should see a
It
picture.
should be an application.
Yeah. So if you go to Start, just search Jupyter Notebook. It won't be
It's
there,
not
but
going to be here, but it should be if you downloaded it on Windows. But if not, if you're on Mac or Linux, just type in Jupyter Notebook in your terminal.
yeah. Does anyone need help or should be fine? If you don't have, if it doesn't work, if you remember, once you open it, you'll see some black screen, which is the terminal and stuff. Just go to your web browser. It will open in your web browser. And once you have it,
Oh, it might ask you to copy and paste the token as well.
oh yeah. If it was a token, then you can type in your address bar. I think local host I think, I'm not sure. I think one's, oh, is it 8?
I think it's A, 0, 0.
Oh, it's A. Oh, so it's A.
Okay.
Yeah.
And then some string.
It's something like that.
Yeah.
But if once you open it, if you go to the top right hand corner, there will be a new button. If you click new, just click Python 3.
Yeah, we can't show it here, but
Yeah, but if you go to the right hand corner, there should be a new button. Right, some new button. I think it's a new button. And if there's a drop down, just click Python 3. Right. Once you have that open, remember you have to download the training data. So if you have Kaggle, oh yeah, we'll be showing you Kaggle. So this is the training data, right? The train.csv. You have to download it in the same directory as. So if you want to put it to desktop, you have to put it. If you put this onto desktop, you will have to in the Jupyter notebooks. You have to go to the desktop area. Otherwise, you can't open it. Does anyone need help for this, or okay, not okay? Yes, fine. Okay. Anyways, for Kaggle people, if you don't have it, let's go to Kaggle. So if you go to Kaggle, and you can also just use Kaggle if you find this complicated. If you make it, so I logged in to Kaggle, you click kernels, right, on the top right-hand corner, click kernels. You go down, there's a new kernel button, just click new kernel, and click notebook. And then you type in search dataset, just type in Titanic. Or you can do whatever you like, but currently let's do Titanic. And just click competitions. And it should be the first one, just click the first one. Oh, just press no, whatever. Yeah. Okay, so this is your layout.
There are some limitations with this, like it can't accept user input.
Oh, but yeah. So just delete all of the, now we're starting. So if you have your Jupyter notebooks and Kaggle, it should look kind of the same. You have like these cell things. In Jupyter notebooks, to execute the cell, you just press Control Enter, right? Control Enter, and it'll execute. Oh wait, you can also do it on Kaggle. Oh. Okay, you can also do it. So if you type in a cell, you just press Control Enter. To add in new cells is like the add button, right? These add buttons. Anyways, so copy paste. Now get to where's the thing? Here, right? Once you highlighted all of this, copy it. Right? This is the helper library, the 115 line one. Right? So you just copy, Control C, and paste it in here. Oh wait, it's already for you. Oh, okay, let's just paste it in. Right? You paste it. And then once you paste this, so you can also do this in your Jupyter notebook. So you just paste it there, and then you press Control Enter, right? Highlight on the cell and press Control Enter. And it should work. If you see a number, go up a bit. If you see that number like, oh you can't see it. Yeah, there's a 3 there, or a 1 or wherever, it means it's fine. It ran.
And if that's not the case, which is more often than not,
it will have an error message on the bottom.
Yeah, there'll be an error here in red.
Press a new cell.
Just some random thing.
Wait, I just did. Oh no, this is function.
You get some.
Right, it will say some error if you did something wrong. Anyway, so you loaded this helper library in, so now let's use it. So if you have Kaggle, so remember, you have to have the training data exactly in the same position where you saved it. So remember you made a new file, the Python 3 file.
All the files have to be in the same directory.
Yeah. You have to put the training data, train.csv, exactly in the same location as where you saved your new file, or made the new file. On Kaggle, don't worry. Yeah. So on Jupyter Notebooks, all you need to do is use the get function, right, and type your training data. Right, this is for Jupyter Notebooks. Oh no, it's a bit different. And then you have to type your target. So this target will be survive, right? So just right. So this is for Jupyter Notebooks, not the Kaggle one. So this should, and then you just press Control Enter. Obviously there's no file here because it's not the same one, but it should work. If you're in Kaggle, where's the file? Files. No data. Oh yeah, if you're in. Oh. What? Oh no. Silly. Oh, let me just get. Anyway.
Yeah, we'll just verify this and then
I would just use someone else's, whatever. So you can. Yeah, okay, doesn't matter. I just use someone else, the same thing. Anyway, so, okay, so in, where's the, yeah, okay. So in Kaggle, the file name is this thing. Right? In Kaggle, the file name is /input/train.csv. Should be the same for everyone. Oh, wait. Stop. Oh, wait, what? Did it get the wrong name? Oh, I have to run it again. I didn't run. Yeah, okay, it works. Anyways. So in Kaggle, this is what you do. Remember, not in Kaggle, it should be that. Okay, this is not this is for Jupyter notebooks. In Kaggle, it's that. And if you do Control Enter or run, it will give some random output. Okay, so this is reading the data. And once you have it, it will give you two different outputs. The first one is the data, right? And the second one is your target. So you have to do data, comma y. So it will be two different outputs. The first one is the data, and the second one is your survived column. So you do it again, and then down. There should be no output if you do that. And if you add a new cell, let's see what it looks like. So if you type data, and Control Enter, you should get this thing, this table. Right? If you do data, it should look like that. If you do Y, Control Enter, it's your survived column. Yeah. So now, before we can do anything, in the helper library, if you see, so before we can put some, oh wait, I think it already did it. Oh, okay, anyways, the helper or library already did all your pre-processing for you. So it converted all the words to like numbers and stuff like that. It deleted the missing columns and don't worry about that. Anyways, so once you have this, now we're going to choose a model. So in the helper library, there are two different types of models called classifiers and regression. Right, those are the two different types of two different types of things you can use. So can anyone tell me what's the Titanic? A classification problem or a regression problem? Yes, classification. So we have to use the classifier module, right? So in the classifier module, data, so you type the data, right? You put a comma, you type your Y, and you type your model type. So let's do that. So the data, right, is the data from the before, right? Your data. The target is Y, right? And what model type? Let's use the logistic regression, which is the one we did before. So if you type logistic, the first one we learned, oh, I did type it wrong. Oh. Right, you do Control Enter. Oh, don't worry about the thing. Anyways, so this outputs the model, logistic regression, right? So you don't have to use logistic regression. Saksham was talking about random forest, and you just type forest. Right, the random forest classifier came out. There's also other methods which we will learn, including extra trees classifier, if you heard of it. So you just type extra, and that also works. There are also other algorithms called boosting algorithms. And then just change the thing, and then you have a gradient boosting algorithm. Also neural networks, which is, right, just type neural. Don't worry about the front error thing, that's fine. So these are the different algorithms you can use. There's also support vector machines, if you heard of it as well. Yeah. And there's also trees, decision trees. So you can do you can check the top. There's like you can use different methods.
In the classification function, all the methods are this regression. Yeah, so here all the different methods are defined.
So random forests.
Yeah.
There's decision trees, extra trees, logistic regression, support vector classifier, boosting algorithms, and neural networks. These are the many multiple algorithms you can use.
And it's based on sklearn, which is a very useful Python library.
Yep.
And it's got a lot of machine learning capabilities. So that's what we're using, but it's all happening in the background here. I mean, the code, yeah.
Okay, so now we have let's say that we use a random forest. Okay, so what this outputs is a model. So we type model equals to, right? So now it's saved as a model. But now I want to predict something. So let me make a new cell. So what you do is you want to predict. So you can use the predict function over here. Right? So you just type predict model and your data. So the original data. You can use other data, but not now. Currently the helper function wouldn't work on other data, but that's running wrong. I did it the wrong way. Yeah, okay, so that's your prediction, right? This is using a model to predict something. So if you change the model, for example, to like, let's just do 0 to, so this is 0 to 10, this is truncating the output. So let's try different methods. This is your decision tree, right? Let's see a different method. Let's do logistic regression. Right? The output is the same from 0 to 10. But maybe later on you'll see some difference. Let's try another one. Neural network. Right, so you look at the neural network. 0, 0, 0, 0, 0, 0, 0. It's different from the other methods. But this is just, obviously it doesn't mean the neural network is bad. I just made it weaker because it's too slow. So you can see how different models can give you different results. There's also support vector classifier, which is the same as the tree method. There's also random forests. Right, it's also this, well, from 0 to 10 is the same. So you can just do different models and you can see what happens. Right, see the boosting model is different. On the third number is different.
Yeah, second loss.
Yeah, and second loss. So these are the different types of models you can use. So, okay, this is classification. Now let's try a regression. Let's see what happens if we change this to regression. Let's see what happens. Let's do linear regression. Let's see what the output looks like. See, the output is continuous. That's like, 0.13, 0.9, and stuff like that. So what you can do is you can also, in many algorithms, there's no classifier. They only use regression. And what it does is you can round the regression off. So if you see 0.93, you can round it off to 1, and that's what sets apart. Everything else you can round off to 0. So the regression, right, they output, see the random forest outputs some different stuff, right? These are, but this is regression. So if you do a regression model, you can also see the extra trees classifier is different. It in fact, even though if you put regression, it outputs classification numbers. So that's very different. Neural networks for regression. Yeah. Yeah, because I made it faster so you will only see nothing. But anyways, so you can play around with this, you can put whatever model, you can do whatever you like, put whatever data set you like and it should work.
So whatever data set you want to use it on, just keep in mind whether it's a regression or a classification task and use it accordingly.
Yeah.
Obviously for Titanic you wouldn't use regression.
Classification.
Classifier.
Yeah, classifier. Control.
And you will get the discrete outputs.
Yeah. So if you want to play around with the code as well, so if you go up, there are these, you can go into the code, right, see the number of estimators I said to 10? 10 is not good. The more, the better. You can do 1,000 if you like. It will be slow, but you can do that. Or you can do, see here, extra trees. If you wanna change it 10,000 forest, 10,000, trees.
Huh?
That's how many trees. So remember, so a random forest is a collection of different trees. So if you increase the number of trees, you'll increase the classification rate.
Sorry, just with the random tree, where's so the formula is at the bottom instead of at the top. Sorry, I'm gonna say the formula, but you know how
Yeah, the fun. Yeah, we call it function. Yeah.
Yeah, function, right?
Yeah, yeah.
So with that random for you're doing like sort of yes and no for each of these.
Yeah.
So you talk about the temperature, how it was tired or whether it rains or not, and all these variables, right? So you say, so the chance of that person playing that day based on these variables, and those sort of kind of work it out down that way, right? They work it out for you. What's the most important? You have to put that yourself first. You have to put the first that's most important, which is the temperature. Was that?
That was random. Yeah, they will be. They will.
Yeah. Do we have to put it? Does he have to put that?
Oh no,
first?
that's all determined by the algorithm.
Determined by the
So
algorithm.
it splits at each node. So the top one is based on the
The most. So we can say it's the one which splits the data the best.
The best. So it provides the best split.
So
So
the-
some condition here, which will be the best way to split this into two
Oh,
nodes.
that thing. This or this.
This or this, yeah.
This or this, right? Okay.
And no, you don't have to do this by hand. It's all done.
It's that by.
It's done at each step. So the function is applied here, then it's applied here, it's applied here. That will tell that and that,
And so on.
and
Yeah.
it'll keep going down.
So in the end, you get 0 or 1 for
Yeah.
your model.
Yeah.
And then so the next data you put in, tired 4 and temperature is 35 degrees. We'll just work it out whether it's going to play or not.
Yeah, that's
Exactly.
So when you have the input data, it just goes through the tree until you get
So it's like the formula or the end product comes at the bottom, isn't it? Sort of.
Yeah. It's
Yeah.
yeah, like a formula.
Whereas putting a formula at the top.
Yeah,
Because
exactly.
Most people that want to predict has this formula, then as you know, they can't predict properly.
Yeah.
Yeah.
it outputs
It's
the
been hard. It's been hard because they try to put the linear regression, all this output,
yeah.
but it's hard because there's more than 10 variables over there, or there's unknown variables out there that they don't know. There could be 100.
Yeah.
So you can predict the stock market or to predict the house price crash.
The algorithm will just go off whatever data you
Yeah.
provided.
But we have to provide as much data that's applicable to that
Yeah.
problem.
The
Yeah.
more accurate, more data, the more accurate the model will be.
Yeah. Well, that's amazing. So you actually write those programs yourself, or?
Oh, for the models are using other libraries. But the helper library, what you can do, like you plug it in. Yeah, that's what I.
But are you guys learning Python to write this coding for AI? I'm not sure what you are. You third year or fourth year?
He's second,
I'm
I'm
second.
first.
Oh, you're the first year.
But yeah, if you want to do coding in AI, yeah, Python will be using
Python is the best.
Yeah.
And as you can see from the code, we use sklearn, as I said earlier. That basically handles all the processes. So it's,
We don't teach. They don't teach Python.
they don't teach Python
No, they
here.
just teach R.
They teach
R.
R and C.
Yeah.
Yeah, they teach R the statistics. Yeah.
Yeah, they teach R.
Python is more used. Yeah.
Yeah.
Yeah, in industry and real life, Python will be more
Python
used.
is the.
And it's also faster, so.
And that's your lecturers.
No, they're not gonna change.
Yeah, I know. It's always been like that for the last 20 years. Yeah.
Okay. I think that's all. There's other. So if you check the slides, there are other different methods. You can just see what happens.
Yeah.
We won't be explaining them now, but it'll be way too complicated. Next week we will be starting on coding the. Should we do the? So most of the I'm assuming most of you came because of the stock prediction. So before you can do the stock prediction, you will have to learn how to do the business part. Because if you don't know how to do the business part, I don't know how you're going to know how to do the stock prediction. So you have to know how to do the business part before you know how to do the stock prediction. Otherwise, you have a big jump.
Stock
So, yeah,
prediction's always wrong anyway, so don't worry.
Yeah, true.
You're only
just-
right by a couple of days. You're not going to be right by a whole month.
Yeah.
A couple of weeks in time to sell it.
Yeah. Anyways, that's all. Wait, yeah, what are you gonna say?
Yeah, we also, I can show the self-driving car simulator next week if you're interested in that. It uses this, what's known as a convolutional neural network as its training I'll get that to work tonight and then show it next week. So it's basically based on convolutional neural networks, which is best for computer vision. Basically, how the computer visualizes the images, its surroundings, and makes decisions based on that. That's how Tesla's self-driving cars are programmed, and I can show the simulation next week. So,
Yeah.
and we'll also get started on the stock prediction next week.
Yeah.
Business bot first,
Yeah.
and then the stock predictor.
Okay, so as you can see the power of artificial intelligence and data science, and we showed you some of the algorithms used. You can play around with the helper libraries and stuff, so you can put your own data in and stuff like that. It will still work, I assure you. And yeah, that's the end. Thanks.
Thank you.